This is my independent study research demo on ray tracing. So, 3 milestones. First one, just learning DX12. Second one, ray tracing fundamentals, and then more DX12 and learning DXR. And then lastly is the ray tracing demo in DXR. So for deliverables, I have a basic DX12 engine, and then I have the ray tracing demo, which is doing ray tracing in a weekend in DXR. And ray tracing in a weekend, real quickly, I'm just going to pull up the website, is Peter Shirley's book for beginners learning about ray tracing. And you end up with this picture at the end. So we'll get back to that later. So milestone one, just learning, like I said before, DX12. There's something that I spent a lot of time on, exploring Mini Engine, which is a game engine that Microsoft has provided to help people have a jump start on DX12. However, I guess long story short is it takes a long time to compile. And I think I kind of looked at this when I wasn't ready to yet. And yeah, it's something I might come back to later. Uh, so yeah, that's milestone one, just basically getting started learning DX12. Milestone two, started learning ray tracing fundamentals by going through Peter Shirley's book. And the high level steps are calculating array from camera to pixel, and then seeing where which object the ray hits, and then just calculating the color. So I'm just going to pull up that code real quick. So in main, we've got calculating the camera, and then calculating the ray color, which involves seeing where the ray is hit, and then based on the material that it's hit, calculate the color. So here, there's 3 materials. We've got the Lambert, metal, and dielectric. And I'm not going to run this demo because it's not real time and you end up with this picture. So we've got the metal, dielectric, and Lambert. And yeah, that's about it for that one. For DXR, which is the basic DX12 engine, I like this tutorial because it showed how to extend Microsoft's Hello World DX12 triangle demo, and it showed where to hook in DXR. And then it was nice to have a switch between the two and just see them both working. So here's a screenshot for DX12's rasterization pipeline, and one of the keys to get this working is they're sharing the same geometry buffer. So in DXR, here's the same geometry, and then using the acceleration structures, I was able to make an instance and then call a different hit shader over here, which I'll run through. So rasterization pipeline is similar to rasterization pipelines, I guess. You have to set each shader and resources before calling draw. And because of that, you need to know which shaders belong to which objects in advance. And in DXR, because any array can trigger any shader, that needs to be available to the pipeline. All shaders need to be available to the pipeline at any time. And that's made possible by a shader binding table. And what are some other key features? So before, when I was going through the ray tracing logic, we do the same thing in DXR. So using RayGen HLSL, that's where we calculate the ray from camera to pixel, and then they get delivered. I'll pull up a shader too, so we can look at code. Okay, so yeah, here's our RayGen, and then calculating the ray from origin, which is a camera, to a hit. And once it does hit, it will trigger one of these shaders, hit or miss, and then the result will get delivered through this payload, and then that's where the color comes back. So if we miss the object, right now we're just returning the background color. So that's kind of like clear color in rasterization. And if we hit, then we can calculate colors here. And this attribute parameter here has a built-in ray triangle intersection shader. And that's how we figure out where the hit point is by using barycentrics. So let's see. I'm going to just go ahead and play the demo now. So we have rasterization pipeline, and then I'm going to hit spacebar, and this is the ray tracing. So we have the hit, which can be triggered on the plane, the tetrahedron, the cube, or the miss, which is this blue color in the back. And then I have a scroll wheel zoom and then mouse orbiting. And then if we want to look at something without it spinning, one of these keys will stop it for A for animation, I guess. So to just quickly go through the differences between rasterization and ray tracing. If I go over to the render, when I populate the command list, there's a raster mode or the ray tracing mode. So in raster, because in raster we need to know the shaders of the object ahead of time, that's where we set the resources and then draw, which is done here. So this is for the tetrahedron, the plane, and the cube. Now in ray tracing, all of the shaders are available at the same time. So that happens through setting up the tables. Okay, and then one of the other things I wanted to talk about was, let me pull this back up. So over here, I have the two tetrahedrons in the cube. So in DXR, the setup happens using acceleration structures, and that's where the geometry data is located. So in the bottom level, that's all the vertex data, and then the top level, it's using the instances, and that's how I have the two tetrahedrons set up. And lastly, this one looks different. That's because once the engine was set up, I wanted to like add new stuff to it. So in one of Microsoft's DX12 ray tracing demo, there's a simple diffuse lighting demo, which I've added here. And so the new work was to add an object, add a hit shader, and then figuring out how to bind it into the pipeline. So if I just go to, let's see, hit, maybe hit group, we'll get to that part of the code. Yeah, so this is where we're creating the ray tracing pipeline. We can use the same hit library, but we add, oh yeah, another thing I added was the cube closest hit. So you'll notice this one is just green and this one has the colors. So that's cube closest hit. And then closest hit by itself is that shader. And then this one would be the closest hit simple lighting for simple lighting demo. And then the shadows are making the shadows. Okay, so let's see, that's where I've added it. And then what am I looking for? Oh, the acceleration structures. Bottom level. Let's see, I think I can just go to create acceleration structures. Yes. So here is where the vertex buffers are created, and then for top level, that's where we can define an instance. So yeah, that's all I really wanted to show for this demo. So let me just close it out and then move on to the next one. So I did, after I got this far, I tried to do the ray tracing in the weekend in this demo, and that's when I realized one is procedural geometry and one is using triangle geometry. Um, so that's when I eventually, long story short, decided to use the procedural geometry demo from Microsoft. And the implementation, once again, is the same. It's just creating the ray, determining where the object intersects, and then calculating the color. Previously, for the simple ray tracing engine, I was using the ray triangle intersection shader, which was built in. But we can also have intersection shaders, which define intersections. And the key difference in milestone 3 is I needed ray sphere intersection instead of triangle, because that's also what ray tracing in a weekend uses. Um, if I pull up ray tracing in a weekend and we look for where hit is defined, oops, then this is the ray sphere intersection logic. And then for the DXR version, it does the same thing. So here's the ray sphere intersection. Okay, so let's go ahead and show that demo. So I've got some keys to move it around. And then similar to ray tracing in a weekend, we've got the metal, glass, diffuse. And then these two rows are using the Phong implementation. And then, so this demo came with some Phong shaders, and then I extended the code to add glass and then did some tweaks to get it closer looking to ray tracing in a weekend. And after that was done, I tried to do the Lambert implementation, which is what this row is. So let's see. So metal, I was trying to do some work with combining diffuse with metal, which is why this is kind of yellowish. Glass, the refraction is working because it's got like the upside downness to it. But this one looks, I think this looks more like glass. And then for diffuse, this one seems okay. It's still a work in progress. I need to do another pass where I compare this implementation to the one from the book. And maybe that will get it to be closer. But yeah. Oh, and I have a key to move the lights around. So that's about as far as I got. And for the last part of my paper, I just talked about possible next steps. I haven't really decided what to do next yet. I could just keep working on getting it closer to ray tracing in a weekend. There was other examples in the procedural geometry demo that I just didn't look at because I just wanted to focus on spheres. And what else? Another one was to just try to add the triangle geometry to this demo, or add the sphere geometry to the previous demo, and then I could see if there are more differences there. That's just a learning exercise, I guess, not really a next step. Engine architecture, I didn't address that at all because I just felt like I was still learning, so I didn't really know how to start this one. But now I'm thinking to bring it closer to ray tracing in a weekend, I could, I'm just gonna close this out. I could add more spheres, and then that would kind of force an architecture into place. So there's that. And then lastly, if I wanted to do even like newer work, I could go and do the second book, Ray Tracing in a Weekend 2, and start looking at how to implement that in DXR. So those are some next steps that I thought of. There could be more. And yeah, that's the end. Thanks.